So we took a population of people that when they joined InsideTracker, their A1C levels would be considered type 2 diabetes, if that was the diagnostic that you were looking at. And we followed them over 4 or 5 blood draws, and that was a couple of years. And what we see is that initially they do improve, but they're still in the diabetic range. But by the end of that time period, those 5 draws, a few years, on average, they've all reached but below that. So they're all now considered still pre-diabetic, but they're not actually considered in that disease state yet.
Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, how to live a healthier, longer life. We are produced by InsideTracker, your science-based guide to optimizing your body from the inside out. Our guests today are Dr. Renee Deehan and Nimisha Schneider. Dr. Deehan is a Senior Vice President of Science and Artificial Intelligence at InsideTracker. Dr. Deehan holds a doctoral degree in molecular and cellular biology from the University of California, Berkeley. Dr. Deehan is a molecular biologist by training and has spent the last decade guiding drug discovery and biomarker development by designing and building high-resolution molecular models of disease and creating systems that find meaning in large-scale biological data. Nimisha Schneider is a Senior Director of Science and AI at InsideTracker. Before joining InsideTracker, she served as the Director of Translational Information and Computational Biology at Quartz Bio, and as a Senior Data Scientist at Precision for Medicine, Patient Like Me, and Solventa. She studied biology at MIT before transitioning to the industry. Welcome, Renee and Nimisha, and thank you so much for being here today.
Hi, thanks for having us.
Thanks, Gil.
So before we start, I would love to have you tell our audience your background. So maybe we'll start with you, Renee, and specifically, why have you decided to become a scientist, and why have you decided to go to computational biology, AI, and machine learning?
Sure. I mean, why I became a scientist, honestly, I love any kind of science. It's all interesting, of course, just like I'm sure you and Nimisha, when you grew up as a kid, you're really fascinated by the natural world around you, and human bodies are crazy and fascinating. And, it's a really nice way to try and make a difference in people's lives, to be able to, work on a disease or work on disease prevention, which is something, of course, really near and dear to InsideTracker. But, ultimately, I fell into computational biology after graduate school, and that was a while back when microarrays were just on the scene. And I remember that people would do these microarray experiments, and it would generate maybe 2,000 data points, and they would just pick their 2 favorite and characterize those 2 favorite and literally ignore the other thousands. And my first job out of graduate school was working with both of you at Solventa, where we really got to use all 2,000 of those data points to figure out what was going on by implementing computer science methods. And I don't know, hooked ever since.
Cool. Thank you for the interesting introduction. And Nimisha, what made you to become a scientist?
Well, I actually started in science in the lab. I was doing basic immunology research for a while after my time at MIT, and doing cell culture and studying one molecule at a time or one cell at a time. I sort of stumbled onto computational biology also through a job at Solventa. Actually, we all started at the same company, where it was transcriptomics. It was being able to measure. Now we do it with RNA-seq and new methods that used to be microarray, like Renee said, but being able to all of a sudden measure every single RNA in a cell. And then I really liked the math piece of sort of mathematically unifying all of that data together to figure out what's going on in a systems sense, like almost treating cells and biology like an engineering system. And so that sort of was my introduction to computational biology. And I've been doing modeling of biological data, whether it be RNA, proteins, other markers in blood as we do, or genetics, ever since then.
Excellent. Thank you so much for that. And Nimisha, let's continue with you. Can you please define to our audience what is computational biology?
Yeah, so in computational biology, it's a pretty broad field, but the aim is to build mathematical models of biological scenarios. And it can be as simple as, we want to see if there's a linear relationship between the levels of two molecules, or we can build more complicated models with lots of different levels of, say, gene expression or proteins in your blood or proteins in any organ. And we can sort of see how they move together or how they impact one another in a logical sense. There's a variety of simple and complex mathematical ways to figure out what is going on in a broad sense when there are lots of moving parts, as happens in biological systems like human health. So that's sort of the basic idea. It's applying the math of modeling and predicting to biological data.
Thank you. And Renee, there are a couple of buzzwords that we are hearing again and again in the recent few years: AI, ML, or artificial intelligence, and machine learning. Can you provide a simple explanation for our user? What does it mean?
Sure. So artificial intelligence also is a very broad field. And essentially what it means is very simple. It's the simulation of kind of human intelligence and human thinking by machines, and especially computer systems. So the way that this works is that there are different processes that include learning from experience or using reasoning to make decisions, being able to self-correct or really predict a particular outcome that we do in our heads, but that we can kind of teach machines to do as well. But essentially at its core, AI is really about implementing algorithms that can perform the tasks that typically do require some type of human intelligence, like speech recognition or, solving a really difficult problem or visual perception. And there are lots of different types of artificial intelligence. One of them, machine learning, is something that you mentioned. And that in itself is a very broad field, but for example, is often used to make predictions about, if you have some data, you can use that data to make a prediction about a certain outcome. So is somebody going to respond to a drug? Is somebody going to, if they take up a new exercise regimen, is that going to impact their blood biomarkers, right? These are the types of predictive models we can make. But there's other types of artificial intelligence as well, like knowledge representation and reasoning, which is something that's very core to InsideTracker. There's, of course, a lot of talk these days about LLMs and large language models, which are a different type of artificial intelligence that uses more probabilistic methods to be able to create the kind of cool chatbots that we have today. There's other things like natural language processing. So really the field of artificial intelligence is very big, and it's very exciting to sort of figure out which one of these great tools that you can use to potentially help solve a problem in, business or society without overpowering.
Thank you so much, Renee, for the detailed answer. And we are here today to discuss a very interesting milestone for all of us at InsideTracker, but I think also for the field of personalized nutrition and the field of basically digital health. So I mean you, Nimisha, you spent a couple of years of analyzing a very big data set, and you package it into a paper that we submitted for a publication, and would like to discuss and explain to our audience what does it mean and what have you found and what are the implications for that. But maybe before we'll get into that, I would love to hear the background about maybe the InsideTracker platform. So what InsideTracker platform is doing and what a user on InsideTracker can expect to have.
Yeah, I can answer that one. So we were just talking about artificial intelligence and the different types of artificial intelligence. And of course, at InsideTracker, there's a couple different ways we use AI, but really at the heart of it is something called knowledge representation and reasoning. And that is our recommendation engine and platform. And that is also called Segterra X. So if you hear us refer to Segterra X, that's really what we're talking about, really is this recommendation engine. So knowledge representation and reasoning is oftentimes used to build what we call expert systems or logic reasoning based AI systems. And the goal of these types of systems is to think like the expert. And in our case, the expert is really a combination of different kinds of experts. So it could be a nutritionist, it could be an exercise physiologist, it could be somebody who really understands sleep and recovery. So, or just essentially lifestyle or preventive medicine in general. So all of that type of expertise, plus expertise in biology and molecular biology, and more kind of the background that, maybe Nimisha and I have, Nimisha, especially with immunology. How do we get all of the knowledge that's in all of these experts' heads into a computer system? And the reason why we need a computer system is because the amount of data that we're dealing with is really large, and the amount of knowledge that we're dealing with is really large. So I'll talk about those two things separately, but essentially what we do at InsideTracker is we match what we know about you and your biology, and that is gathered from physiomarker data that we might collect from asking you questions about your health, like your body fat percentage, or it might be from your fitness tracker, which tells us information about how you slept last night or for the last 6 weeks, what activities you do, how many steps, what's your VO2 max estimate, but also the blood biomarkers that we measure. And you can get up to 48 of these. And then on top of that, we also have a genetics aspect of the product. So it can take all of that information about you and essentially kind of get a high resolution picture of your health at that point in time. So that's the data piece. And then that's married with knowledge that we have captured from over 7,000 clinical studies. And we know that, of course, no human can read and digest the findings from 7,000 clinical studies and remember all of that and then apply it to all of that data that we have about one specific person at one point in time to figure out which of those findings from those 7,000 papers are actually the most relevant to you and are going to be the most helpful for you. So that's why we had to build this AI engine that we did, so we could really do that at scale and try to recapitulate the knowledge that these experts have in analyzing your data and applying the findings from those clinical studies to figure out what is best. So knowledge representation and reasoning really has two parts. The first is knowledge representation, and that is essentially reading those papers and capturing all of the most relevant information from those papers, like how many people were in the study and what was the intervention in the study and what was the outcome of the study, and putting that in a format that the computer can read. And the second part is really the reasoning. And that's where the expert really comes in and says, okay, well, given all this stuff that we learned from the clinical studies, what is the logic that we can use to apply it to certain people? Like if you find that, consuming olive oil is really beneficial for people with high LDL, we would want to say, okay, well, let's only give that recommendation to people in our platform who have high LDL and who may be over the age of 65 and female. So we can provide that sort of level of personalization to it. So that's how we use essentially a computer science methodology to make these personalized recommendations.
Thank you so much. And maybe before we dive into the current manuscript, can one of you provide the background of the previously published data from InsideTracker and what was the conclusion from that?
Yeah, I can do that. So a paper was published several years ago, which took the group of users who were taking part in the InsideTracker platform and looked at their measurements of various biomarkers in their blood that are connected to cardiovascular, metabolic, and other aspects of health, and looked at people who had tested multiple times and saw, did they actually improve? So, as Renee said, there's a lot of expert domain knowledge about health and nutrition and exercise and various lifestyle interventions that's in our recommendation engine. People interact with that recommendation engine dynamically. They tell InsideTracker lots of information about themselves, how they sleep, what their stress level is, what their general nutrition and habits are, exercise habits, etc. And then they get their blood tested and their recommendations come back to them based on all of that information. So it's not just you have high LDL, here are the recommendations to lower it. It's here are the recommendations for the specific kind of person you told us you were and your specific existing habits and sort of the context of that person's health, which is fantastic and based on very rigorous trial data, which, as we sort of know, the clinical trial is the rigorous way to isolate variables and figure out if they'll actually make a difference to things like LDL. But what we wanted to do is look at what actually happens when we give people that information in the real world and they try to incorporate those recommendations into their lives. And then they come back and get their blood tested again. So that paper examined a cohort of 1 to 2,000 people and showed that overall, on average, people were improving. And they were improving in the specific ways that they had chosen their recommendations to improve. So if they had chosen to focus on heart health and gotten those heart health recommendations, we see improvement in their cholesterol and other lipid markers that are commonly associated with heart health. So that was that. The other thing that paper did, which was very nice and sort of important in this field of general population health, like not necessarily people with a specific disease, but a group of generally healthy adults who are seeking to focus on greater health, maybe for more preventative reasons, is that it looked at how all those biomarkers moved and worked together. And some of that information is things that we already know, like we know LDL and HDL, cholesterol and total cholesterol are sort of going to be correlated. Those are biologically related. But it also revealed some kind of novel things that we didn't necessarily know. And it really highlighted especially the importance of the link between metabolic and cardiovascular health, which we've shown in other people have shown in other very detailed molecular biology ways, but it's very nice to see it in a real world cohort.
Excellent. Thank you so much for the detailed background. And now let's switch gear and discuss the current work or the current paper or manuscript that we just submitted. So, Nimisha, what led you to decide to initiate this study? Why have you decided to do that? We already have a paper from 2018. I think that's very good. So what made you and Renee and the other team to decide to research it and come with a new study?
Yeah, so there were a few things. I mean, the first motivation is really always, in the case of both papers, to show that this digital health platform as an intervention is actually correlated with improving health. And the first paper did that. And what this paper really adds is a couple of things. Number one, it's a cohort of about 20,000, which is a massive, sort of unprecedentedly large cohort. And that gives us an incredible amount of confidence in a statistical sense, like just statistical power. We have a very large group of people. We're not as worried about random variables sort of skewing the results. We can really feel like the trends we are seeing are meaningful hypotheses about what is actually happening to people. But that is really an expansion of the first paper, sort of a let's make it better with a larger sample size and a larger statistical power. But we also now have other types of data that we've been collecting through the InsideTracker platform for a while. First, we have genetic data. So people who choose on the InsideTracker platform can have their genome sequenced, and we take that sequenced information and we translate it into a series of calculated genetic risk scores. And it's risk of things like having high cholesterol or having high glucose levels. So it doesn't tell us necessarily about what their actual cholesterol level is. We need the blood test for that, but it's telling us what their pre-existing genetic risk is. And we now have a pretty large cohort of people for whom we have that genetic data and their blood data. And the other major thing that InsideTracker has done in the past several years is allowed people to connect their personal fitness trackers to our platform. And that lets us collect on a daily basis data about their activity, readouts of fitness like VO2 max or resting heart rate, and sleep data. So people can give us information about how long they sleep, but also many of the trackers that people are using actually differentiate between sleep phases. So we can get information about how much deep sleep, how much REM sleep, et cetera, they're getting, how efficient their overall night of sleep is. A lot of information about sleep quality. And so what we really wanted to do in this paper is to integrate all of that data together to not only show that people's health is improving with use of this platform overall, but also to see what insights about how that improvement happens can we give people, what connections can we make for them that will use multiple pieces of data and sort of can help guide our users to what is the most impactful way to use our platform going forward.
Excellent. And you just said that the size or the demographic is like 20,000 people, which is huge. And it's like maybe 20x or almost 20x than what we had in the first study. Can you double click on the demographic, talk about the ratio between male and female, and maybe what ethnicity, what is the BMI, and so on for our audience?
Yeah, so I'll talk just a little bit about I'll call it biological sex. I guess maybe we should take a little aside into gender versus biological sex here. So we ask people for their sex, which is based on sort of the hormonal biological definition of sex. A lot of people come to us with a question about gender identification versus sex. And the way that we handle that is that, we consider you to be biologically female if you are doing, for example, like a hormone replacement therapy or some sort of hormonal therapy, whether or not whatever your assigned gender at birth was. So that's just a note about what I mean by sex here. We do tend to have a cohort of more male than female users. And our cohort is not the ethnic breakdown is not sort of as diverse as, say, the general US population is. So we have a real bias towards males of Caucasian descent. And that's something that we're aware of. And it really has to do with who the market has historically been for this product. But it is scientifically relevant because we want our analyses to be applicable to whoever is interested, and we don't want them to be biased towards one particular group. So from a sort of product perspective, we are making real efforts to see that our product is relevant to and reaches more demographics as we move forward. But from a scientific perspective, it's really important that we know who we're mainly looking at. So we're about a 40-60 female-male breakdown. And in terms of ethnicity, we're a little more than 80% white or Caucasian ethnicity. And then one of the other things that, as Gil mentioned, that we look at is body mass index. Although I will say that InsideTracker is not, super into BMI as a health measurement for various reasons. It's been shown to be sort of problematic as like a really granular measurement of health. But as an overall look at the cohort, it gives you some sense of the sort of where your averages are falling out. And we have an average BMI for both men and women in what the WHO would term the normal BMI category. In terms of age, we're maybe skewed a little bit older than a cohort like people might be familiar with NHANES, which is a really big American general human health cohort, or UK Biobank. We have sort of a late 40s mean for our age. And that, again, has to do with who the market has historically been for this product. So those are just some things to be aware of about the cohort.
As a Longevity by Design podcast listener, you understand the value of improving your health for today and for all the years ahead. And if you want to live your healthiest, longest life possible, you need to understand what's going on inside. At InsideTracker, we take a personalized approach to health span optimization that eliminates guesswork from your wellness plan. InsideTracker analyzes blood biomarker and DNA data, along with physiomarker data from fitness trackers like Oura Ring, to deliver personalized food, supplement, lifestyle, and exercise recommendations that allow you to take control and improve your health span. And for a limited time, Longevity by Design listeners can get 20% off at the InsideTracker store. So if you're ready to receive a personal health analysis and data-driven wellness plan to optimize your body for the long haul, then it's time to start inside. Visit insidetracker.com/podcast to get started today. That's insidetracker.com/podcast to get started today.
Excellent. Thank you so much for providing this information. And again, as you hear, Nimisha is a hardcore scientist, so she providing the data in a very precise way. And I think that it's great to hear a scientist doing that and not providing a more high level. So thank you so much for going very deep for that. And now I'm excited to go into the meat and potatoes and discuss what have you found, you and Renee and the team. And I would like to start with genetics, and specifically, I hear a lot of people saying, "Hey, my grandfather had the cardiovascular disease, so I'm going to die from that, and I'm doomed, and that's it." And I think that in this study, we looked at something that allow us to look at a specific genetic trait, and based on that, to see what this genetic trait explain in a specific, for example, for ApoB, which is a very important marker for cardiovascular diseases. So maybe start with explaining our audience what is genetic trait and what have we done and what have we found. I think that's very exciting and completely different than what I said before.
So maybe Renee, I'll let you explain trait like genotype versus phenotype and what our traits mean, and then I can tell you what the actual findings were.
Sure. So like Nimisha mentioned earlier, we have these polygenic risk scores. And essentially what they are, it's looking at different areas of the genome that have been associated with something, right? So for example, we might identify all of the areas of the genome that have been associated with people that have higher LDL cholesterol or people that have higher ApoB, or something like that. So the higher LDL cholesterol or the higher ApoB would be considered a phenotypic trait. And then your genotypic trait is really, at the actual DNA molecular level, what is the base pair and what is the order of base pairs in that, in that region that make up, different variants. And then we combine information from all of those variants together into this one score. And overall, that score will give you an estimate of, what your risk is for a given phenotypic trait. And what we looked at in this paper were things like blood values, but of course, other phenotypic traits could be things like what is your potential rather than risk for having a greater grip strength, or, what is your risk of having, going into menopause early, for example.
Yeah, so what we did here in this paper is we pulled out specific risk scores that were directly tied to what we mean by traits is what people's actual blood levels of specific markers are. So the trait is like what you're actually seeing in your body, and the genotype is what your genome says. So we took those genetic scores, for example, risk of high ApoB. You get a numeric score for that. So the higher the score, the higher your risk of having high ApoB levels in your blood is. And then we took people's baseline measurements when they first come to us before any intervention of ApoB itself. And we just examine whether there is a linear relationship between those two. And the stronger the linear relationship, the more we say that genetic trait or that genetic risk explains that ApoB trait. And so what we see, which is iterated in other studies like this, is that Our strongest relationships are with certain red blood cell phenotypes, followed by ApoB, actually. So ApoB, total cholesterol, and LDL are, I'm gonna say highly explained by genetics. What that actually translates to is about 10% or 9 or 10%. That's pretty high in terms of genetics explaining things. So to give you like a benchmark, I think eye color, which people sort of think is completely genetically explained, I believe it's actually about 50%. So that's like sort of, that would be like one of the strongest genetically explained traits. So this is that's a pretty strong relationship, and it's very important for people who are going to try to work on those levels through lifestyle interventions to know that. It helps, first of all, focus where they want to really, what interventions they want to choose to do, because they can't necessarily do everything at once. But if they know they have certain risks associated with heart health, they might want to focus there. It also is an opportunity to trigger a conversation with your doctor. If you know you have this risk and you're seeing it read out in your phenotype, your blood test again and again, that is something that, can push people in that direction.
Excellent. Thank you, Nimisha. And I just want to add to that, I agree with Nimisha, 10% is a lot, but still it showed that there is a lot about the environment and the lifestyle. So even if you have, let's say, ApoB, that you have a high risk for having a high level of ApoB, doesn't mean that you're doomed. It might be that you need to work harder and change your lifestyle and change your diet. So again, just remember that there is a lot of things that you can do based on your lifestyle, diet, exercise, and so on. And then you started the work in this paper. The first figure is basically, in a way, reproducing what we published in the first paper, but in 20 times more data. So can you discuss what have you found, and was there any difference between what you found with that in this paper or in this work than what we published in 2018?
Yeah, so we see it with this number of people, we see an average improvement in almost every single marker that people are flagged to people to work on. So they're out of the optimal range, and InsideTracker tells them, we think you should work on this, and here's how. Part of that is that we start with people who are out of range, and so there's some movement towards going to the sort of normal level that will always happen by random. But what we now can do with this data set, which we couldn't do before, is to look past that first follow-up blood test and see if the improvement that we're seeing in people, so they get their blood test, they have 3 months plus of interventions, 3 months is the minimum. Whatever lifestyle changes they choose to make, they can track them through InsideTracker. They can say something's not working for them and try something different. But after that 3 months or more, they have a follow-up test. But then we have many individuals who have been using InsideTracker beyond that first follow-up. So they have multiple tests. And that lets us look at what happens after that first improvement. And what we see is that people really sustain, or in some cases continue to improve their levels. And the places where we see them continue to improve are these really key cardiometabolic markers like ApoB, LDL, total cholesterol, A1C for metabolic health, and glucose. And we know those, and that's really nice to see because we know that moving those takes longer. And we can see that in the initial improvement. They're improving, but they're not necessarily completely optimizing, or many people are not able to fully optimize. Some percentage of people always are, but if we follow those people for longer, we see them get even better. And that is really nice for a few reasons. First, it seems like this is, you kind of worry about a digital health platform that is giving lifestyle recommendations, that there's some novelty effect, or like at the beginning, it's easier to do these lifestyle changes, and then you kind of fall back into whatever your previous habits were. And it seems like whatever people are doing that's working, they are able to sustain it. So that's really nice for us to see. But I think it's also nice for our users to see that it takes a while, and you do get there, but you might not get there in 3 months. And Gil, I don't know if you want to talk about this yet. We had some really interesting type 2 diabetes related results that
to discuss that because that's fascinating. So basically, you follow the user for up to 6 different blood tests in a time span of a few years, correct?
yeah,
And
up to 4 years. Yep.
4 years, which is I don't know any real paper that scientific paper that or scientific study that follow them for so long, and you see that a digital health platform or the output of the digital health platform allow them to improve the level of metabolic related biomarkers, but also either maintain them in a better way level or even continue to improve it over time. That's correct?
Yeah, and Renee's going to say it if I don't. I feel the scientist in me feels the need to point out that use of the health platform is correlated with that improvement. It's not a randomized clinical trial with a control group. So there is no control group. Everybody we studied was using this platform. So all we can say is that they were using the platform, and this is the pattern that we saw while they used it. But with such a large cohort, that's a very good hypothesis with that type of correlation.
Yeah, and if I recall correctly, for each of those subpopulation that started with out of optimal or normal level and had a follow-up for 5 or 6 times, we had hundreds of people. So it's not like 2 or 5. The N is pretty big.
Right. We don't have all 20,000 that we've followed for 4 years. Some of them have joined more recently. Some of them got 2 or 3 blood tests and then didn't use stopped using the platform. But in those groups of the very long-term follow-ups, there are hundreds of people. Yeah. So it's still a pretty decent size.
Yeah. So for me, at this point is a key point to show that, and again, I will take all the point that you raised, that it's observational study and so on and so forth, but it's show a correlation between using of a digital health personalized recommendation platform for the long haul and showing that in a way those users can improve key biomarkers related to health, but also maintain them or further improve them for the long term. And if you look at something as simple as weight loss, we know, and a lot of us have try to lose weight, and a year or 6 months or 2 years, you get back to the baseline. So basically, you lose weight and then you gain it back. What is nice here, in my opinion, is that basically you continue to be better. So you, in a way, and again, it's a correlation, in a way you adopted the behavior that allow you maybe to overcome the issue that you have, and maybe you adopted this behavior for life. Maybe, we don't know, but that might be one of the hypotheses. Renee, do you want to comment on that?
Yeah, sure. And I think one thing that is interesting to think about, and it's probably something we can investigate more from a statistical standpoint too, is especially with data that carries over 4 years, we know that a lot of these biomarkers are directly correlated with age. And of course, I think maybe in all cases, if not most of them for sure, are negatively correlated with age in terms of, right, like your LDL is likely to be higher when you're older compared to when you're younger, right? So, actually seeing that people are able to improve that biomarker and then sustain that biomarker over 4 years is pretty incredible when you think about how it should be going up anyway. So, that sustaining is a bigger jump than what would have normally happened, kind of probably if we just looked retrospectively at historical.
No, I agree.
And
it's
we would need
to
do
point.
Experiment
for
study.
great
Yeah.
Yeah. And Nimisha, you wanted to talk about the small subpopulation that we research about, the diabetic small subpopulation. Please elaborate on that. I think that's exciting as well.
This is a result I'm super excited about. I will upfront caveat it by saying that, like Gil said, it was a pretty small subgroup of people, and we're eager to visit it again with a larger group, as we collect data in the future to sort of confirm what we saw. But in the case of the marker A1C, which is glycosylated hemoglobin, it's a measure of what % of your hemoglobin have this glycosylation. And it's a readout It's essentially a readout of the average blood glucose levels that you are running on a daily basis, which makes it such a useful metabolic biomarker. But the interesting thing about this marker is that it is used as a diagnostic for type 2 diabetes. So a specific level of A1C is considered type 2 diabetes, and then there's like a range right underneath that's considered pre-diabetic, and then there's a normal range. And that gives us this opportunity to look at a directly look at these markers in a directly disease relevant way, which our lipid markers are very tightly linked to heart health. I think most people know that, but are not necessarily diagnostic in and of themselves. So we took a population of people that when they joined InsideTracker, their A1C levels would be considered type 2 diabetes, if that was the diagnostic that you were looking at. And we followed them over 4 or 5 blood draws, and that is a couple of years. What we see is that initially they do improve, but they're still in the diabetic range. But by the end of that time period, those 5 draws, a few years, on average, they've all reached but below that. So they're all now considered still pre-diabetic, but they're not actually considered in that disease state yet anymore. And that is huge for us because it's showing this use of this platform, which is it's encouraging nutrition, exercise, and lifestyle interventions, very doable, very tailorable to your own lifestyle, that, you know, hand in hand with this platform, people are actually able to move from a disease state to a potentially non-disease state. And that is wonderful to see. It is also very informative that it didn't happen right away. It didn't happen in that first 3-month intervention. They improved, which is still good. Lower is better, even if you're still in the disease range of A1C. But to get out of type 2 diabetes territory took a couple of years. So I think that the result is great, but also the time frame is really good information for our users to have.
Yeah, that's really exciting result. And we discussed genetic before, but as a follow-up question, I know that you looked, or the team looked, basically what is the correlation between someone that have high risk for a specific marker versus low risk versus average risk, and the effect of the improvement of a specific biomarker. So can you elaborate on that and tell us what you found?
Yeah, so that's sort of the extension of the experiment we were talking about before, where we link your baseline blood marker levels to your genetic risk. We then, because we have this longitudinal data set, we looked at the correlation between genetic risk and people's ability to change. So in other words, if you have a risk of high LDL, is it harder for you to actually lower your LDL than it is for somebody who also has high LDL, but they have a low risk? And we found, so we don't have quite a large enough cohort to do it systematically. So we sort of had to look at the markers for which we had the data. But we found that in the case of cholesterol and which is an important blood iron level marker that is linked to endurance and recovery and lots of other, also heart health actually, that genetic risk does actually make it harder to change, or at least it's correlated to less change. And again, you know, it's a very similar result. So, you know, risk makes you higher, but it's also important to know that risk is going to make your journey on trying to lower those markers slower or more difficult than it is for someone who maybe started exactly in the same place in terms of their phenotype, but they have a lower genetic risk than you.
Yeah, that's a very interesting result. And again, it showed the power of the data that we collect, and basically doing a computational biology, system biology. When you collect a lot of different kind of data, you can look at the intersection between them. And then if you have genetic and blood, you can come say, what is the effect of genetics risk on the level of the blood? And definitely you showed the very interesting results. And speaking of which, a very, I would say, cool.
Can I just, sorry, Gil, to interrupt you. I want to make sure I say one more thing about that result
Absolutely.
before we move on. It sounds like bad news. Like it sounds like, oh, I have high risk and I have high cholesterol and I'm never going to be able to change it. But it doesn't have to be. I think it allows people to really focus their attention on a specific marker. And we do still, people are still improving. It's just a slower slope. So that's just important for anyone listening to know. It's not like a sentence. Your genetic risk is not, a prison sentence. It's just a way to know how to focus your energies and to know, what's more likely to be hard for you.
Yeah, a very good point, Nimisha, and I agree with you. And also the difference between them wasn't huge. So it's harder, but you can still improve it. Absolutely. So
throw in that one just to add to it, because the question about kind of cholesterol and genetic risk, it actually comes up a lot. And we had a kind of customer just in the last couple of days ask the same question, and we didn't have their genetic results in, so we couldn't really look yet, but they were saying that they were struggling to lower their cholesterol even with the recommendations. And so we asked, really, we need to know specifics, like exactly what are you doing, and how compliant are you, and all of this kind of thing. But the other thing to think about here is if you don't know what your genetic risk is for something, especially like cholesterol, which is so pervasive, or metabolic disease, right, is you can look at your family history. If you know your family history, because lots of people don't, but it's important to think about what's going on with your parents. Do they have heart disease? Have they been on statins? And I'll give you an example. So my mom's side of the family, always on statins. I know I have a genetic risk of, an increased risk of diabetes, and that sort of runs there. But if you look at my dad has, does not eat enough fiber, does not have a great diet, but his cholesterol is amazing. So if you're in that type of scenario, then there may be something lurking in your genetic background that is making it more challenging for you. And I would say that if you are struggling to, make improvements after you've tried all these lifestyle changes, then, sometimes you might be a great candidate for a medication, and it's worth talking to your doctor about that. But, or like you said, it may just take longer, or you may have to be more extreme about the lifestyle changes, perhaps, but it is personalized, right? So that's the cool thing, is you try it and see if it works. And if it doesn't, maybe move on to a different LDL lowering recommendation.
Yeah, and I just want to echo what Renee said, that it's not a shame to start being on statin if your lifestyle is not working. And by the way, I have a similar situation. I tested my genetics and I realized that I have a high risk for high cholesterol, and I tried everything and I couldn't take it down. So I'm using a statin right now, and it's better to take a statin than to be in the ICU. So everyone that try and fail, go to the next intervention. So drugs are not bad, but try not to use them if you don't have to. So very good point, Nimisha and Renee. And Nimisha, I would like to go back to the paper, and again, a very good experiment that you have done, I think very smart also, is, and I'll try to explain it, and I'm sure that you will explain it better, is basically, if we are getting back to the cholesterol, we have seen that on average, our users improve the cholesterol, but some of them have been responder, meaning they really improved the cholesterol, the other haven't improved, or even they made it worse. So that's the non-responder. So you decided, let's look at those two subpopulations and try to see what distinguishes between them, and maybe then use it in the future to provide a personal recommendation for a subpopulation. So maybe describe what I described in a better way, and then try to explain to us what have you found.
Yeah, no, I think you explained it perfectly. We first look at our whole big cohort and what happens to them on average. And on average, people with high cholesterol and high LDL and high ApoB improve. But that, of course, the average doesn't sort of describe everybody. There are people who are not improving, and there are people who are improving a lot. And so we stratified our group of high cholesterol individuals And we defined them as improvers or non-improvers. And it was based on the zones that InsideTracker uses, prior domain knowledge combined with demographic information. So my zones might be different from yours or Renee's, but we defined improvement in that way. And then we said, okay, let's look at we have access to all this fitness tracker data, which is activity and sleep data. Let's see if we can characterize those improvers. And we wanted to characterize them in a couple of ways. First, when they first come to us right at baseline, is there anything different about them? For example, are the improvers like starting off lower? And that was the first thing we checked, which was not the case. If anything, the improvers are starting off slightly higher. But also, what did they change after they got those results? So we looked at their fitness tracker data before that first blood test. We looked at sort of the month or two before. And then we looked at what the fitness tracker data was telling us they were doing and how they were sleeping between those two blood tests. And what we saw really nicely, actually, was that step count, which is like, a sort of bread and butter activity tracker thing. Like, people have been wearing pedometers forever. It's like not the fanciest thing that these trackers have to offer, but it's a very good proxy for general activity. And both improvers and non-improvers, so pretty much everyone coming to us with high cholesterol, was on average getting less than 10K steps a day. And 10K is this sort of like often recommended level. They were probably in like 8,000 to 9,000 a day. So not terrible. But the improvers, as soon as they got their result back, almost immediately within the first month of getting their results back, they increased their steps to more like 11,000 to 12,000 a day. And they sustained that increase throughout the entire period, which is, I think it's on average 6 to 8 months between tests, but anywhere from 3 months up to a year. And they were the ones who ended up improving their cholesterol levels, whereas those who didn't remained at that 8,000 to 9,000 steps, which again is not totally sedentary, but that change, and it's not a huge change. That's, what is it? A couple of miles, maybe a mile a day that they're adding. It correlates with this difference in results on the next blood test. So can we say, like, here's the secret, like you walk more and it's going to cause lowering cholesterol? No, I mean, again, we've emphasized that's not the kind of study this was where we can really assign causality that way. But it is a really nice hypothesis and a pretty clean pattern to see that improvers made a big change in their activity, and exemplified just by step count, so walking, whereas non-improvers didn't. And then the other thing we found, which is a little maybe harder to explain, but still very interesting, is that even at baseline, our improvers had higher quality sleep in that they get a little bit more REM sleep per night. REM sleep is not the only readout of sleep quality, but it's a pretty important one. And, what the connection, if there is a true biological connection between REM sleep and lowering cholesterol, what that is, I'm not sure. It's actually not super well studied. There's a lot of studies that say that exercise improves REM sleep, but there's not necessarily a lot of studies that put the REM sleep first and say what's downstream of that. But, we could hypothesize things like quality sleep is good for mental health, and it's just in general good for waking, feeling refreshed, which is conducive to higher activity levels and things like that. So it's a little bit of a less direct correlation or observation, but I think it really emphasizes the importance of sleep health, which is something that's kind of easy to ignore and take for granted, but it does seem to really make a difference.
Yeah, and I just want to add, Nimisha, that again, it showed the power of combining different data sets. So we have blood, we have DNA, we have
exactly.
Activity tracker, and when you have them together, a smart person like yourself or Renee can make a lot of goodies, like cook a lot of goodies out of it. They come with a lot of interesting data points or interesting output that might help us later to make a smart decision. What should we do in order to optimize or improve our health?
And also users can look at their fitness tracker every single day, and they can change their step count today, and they can change their sleep tonight. So that's really nice I think it's really nice feedback for the people who are actually using our products to have that these are really actionable things.
Yeah, absolutely. So I would like to try to wrap up this chapter of the discussion and to ask maybe both of you, if you would like to take one take-off message from this study, what will be the take-off message for you, Nimisha?
Do you want me to go first? Okay, so to me, it's really what I want to tell people that are coming to the preventative health in any capacity is that it's time. It's not nothing that we're talking about here. I don't think anything that exists for these aspects of health is an overnight or a quick fix. So I know people are hit with a lot of information from a lot of sources about how to get younger instead of older and like optimize everything. But just like what we really see here is that picking a few core things, and these are things like eat more olive oil and walk more and stuff like that. They're not, they're not super fancy, expensive things. And sticking with them is really what we see helps people.
Okay, so let me translate what you're saying to my language. What you're saying, there is no silver bullet. You need to work hard. InsideTracker can help you to provide you the recommendation, but at the end of the day, it's hard work for you to work hard. And
yeah, I mean, sure. I know that these things are hard, but I would actually argue that some of them are maybe not as hard as we think. Like walking it doesn't mean you have to like go on a super long walk every single day at a certain time. You can just get fitted in over the day. And sleep is also like even just drinking less alcohol or less caffeine in the afternoon and evening, like that can help your sleep quality. So those, I would say they're not necessarily easy, but they are simple, and sort of giving those simple things time to help, I think is really a key.
Got it. Thank you. And Renee, what is yours?
It's actually really hard for me to improve upon that because I totally agree that we live in a world right now where everybody's looking for the magic bullet, or, folks are really getting super optimized by doing lots of strange things that do take a lot of time or money, or they're taking a ton of supplements and actually ruining their liver health in the meantime, when just kind of going back to the basics. And, what my trainer always says is it's a tripod of nutrition, exercise, and rest, right? And rest is sleep, but rest is also meditation or relaxation or getting into nature. And, you have to have there has to be a balance of all three of those things. But I love my fitness trackers a lot. And I totally understand that lots of folks out there would just prefer not to be tracked and measured. But if you want to wear a fitness tracker, you still generally have a good idea of how much you're moving in a day and how much you're sleeping in a day. And, maybe you don't need the quantification on your wrist at all times, but I loved that last result so much. Like the one where we showed that, the improvers were taking more steps. And I think I just looked, and 4,000 more steps is 2 miles. And I would say, like, you don't even have to take that like super literally, right? We looked at steps, but like Nimisha said, it's a general kind of estimate of activity. And I don't want the cyclists to get mad because they're always like, but I cycled like 70 miles today and took, 4,000 steps. It's a population level study, so it all equals out. But
yeah, that definitely counts.
What?
That definitely counts.
Yeah, that definitely counts. But we're like not meant to sit at computers all day long. We're just not. And like being indoors and all of that. So just finding any way to move your body, whether it's steps or whether you're standing up and doing like, air squats. There was a paper on that recently, N of 20, small, but just any type of movement can really make such a big difference. So for me, myself personally, like that's the easiest thing for me to do. That's easier than eating healthier. It's easier than sleeping more. So I'm a little biased, but yeah, simple but not easy, I guess.
Excellent. Thank you so much.
What about you, Gil? What do you think?
Oh, now I need to say.
Yeah.
I agree with you. I think that my take-home message from there are a few take-off message for me. The first one is showing a digital health platform can work. And we are not the only one, by the way, that published something like that. There are other publications that starting to show, and it's good, that basically digital health and personalized recommendation are working, providing a good value to the users. Again, none of them is well controlled that you can say it in 100%, but there is a lot of evidence right now that something like InsideTracker can work. And the second one is that I like the first data about the genetics that showed, as Nimisha said, 10% is a lot, but in another way, I'm looking at the other side and come and say, hey, guy, don't blame your genetics. Even if you have 10%, you still have a lot of percentage that are not genetics, and you can work hard and improve it. So I think that's another nice take-home message. The second one, to show that a digital health platform like InsideTracker might allow you to not only to improve your blood biomarker, but also allow you to keep it in a better way for a very long term, for 4 years. So that's also amazing. I haven't seen anything that show that. So basically, it's good for the long term. And again, we are a health span, lifespan company. So you don't want to do it for a year and then, again, getting to the bad habits. So it sounds like it's allowing you to get in the right direction. And definitely the last data point that both of you discussed, that we can start to understand or to realize what distinguish between responder and non-responder. So I think that all of that together is very exciting, and that's why I'm excited about it. And I want to finish our discussion because we got to a time, and this discussion took longer than what I anticipated because it was so exciting and interesting for me. So I would like to thank you, Renee and Nimisha, for the great discussion. And we look forward to explore the research in the field of longevity each month with you and the leading scientists. For more information, please go to www.insidetracker.com/podcast. So again, thank you so much, Nimisha and Renee. And I hope to have you coming to another episode of InsideTracker soon to discuss another exciting discovery from our data science and the AI and ML department in InsideTracker. Thank you so much.
Thank you.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by InsideTracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out, using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit InsideTracker.com/podcast.